Hello everyone, this is Mike and welcome back to the channel. In today's video, we're going to be going over something called remoting in parallel. So we're going to use this in PowerShell when we want to process a large number of computers. So let's say you want to run a script against 100 computers, 1,000 computers, 10,000 computers. What are the different ways that we can utilize that allow me to speed up the operation, but aren't necessarily shown in the PowerShell training that's available out there if you go, take a PowerShell class at your local IT training center or something like that. So we're going to talk about a couple methods here. The first method is going to be using the new set of parameters that come with the foreach-object commandlet that's in PowerShell 7. So specifically, we're going to use the parallel parameter. And again, just to note, this is a PowerShell 7 only issue, all right, or only feature. So the script where you're running, or the computer where you're running the script on would have to be PowerShell 7. Right? And the computers you're reaching out to, those could be a mixture. But the computer itself, where the script is running, PowerShell 7. And what this new parameter does for me is it creates a new run space for each loop iteration. So basically a PowerShell run space, think of it as kind of like a space in memory that a separate, let's say, task sequence and commands and whatever are loaded into. And basically you will get a run space for each computer that needs to be contacted at the same time. So if I'm telling the script to contact 5 computers, it'll create 5 run spaces at the same time and go ahead and use each one of those to contact one of the computers that we want to go, do something against, run information against, what have you. So there is a parameter that you could specify the throttle limit on it. But by default, it does work on 5. So if you have 10 computers that you want to contact, it'll basically do it in 2 groups of 5. And so basically the 5 run spaces get created. When one of them finishes, the next computer on the list can jump into that run space. And so basically you have 5 run spaces going until you have worked through all of your computers. So basically it's contacting, 5 computers. It's keeping 5 computers open at a time. And if you get down into the weeds of it from different things I've read and different research I've done, each run space utilizes a separate thread off of the current PowerShell process. So it does not open a new PowerShell process. It uses the thread that is there. All right, so this represents our first method that we could use to contact, let's say again, a bulk or a bunch of computers. So the second method would work within either version of PowerShell. So if you still have what comes with your computer, which is PowerShell version 5, or if you have upgraded and installed the standalone PowerShell 7, background jobs are there for either. Right? So background jobs are definitely a concept that is taught in the beginner PowerShell classes that are available out there. I know I've taught this a billion times. And they are there for us to utilize. Right? So for each computer that we want to go contact, right? So each loop iteration, that would be a different computer, a background job is created to do that. And if you've ever played around with background jobs, you know that you can create more than one of them at the same time in an existing PowerShell process or session. So every time you make a background job, it does create a separate single-threaded PowerShell process. So if you want to contact 5 computers, it's basically creating 5 separate PowerShell processes. And there's no mechanism to throttle the amount of background jobs. Right? So what that means is if you want to contact 100 computers, you don't necessarily want your computer launching, 100 background jobs at the same time. That will definitely affect the performance of your computer that you're running the script from. So you would have to build throttling into the code that you're going to run. Right. So I'll show you guys how to do that. There is a way to achieve that, which is not too much code, but it does, again, add a little complexity to the affair here. All right, now, the two methods that I'm talking about here, foreach object with the parallel parameter and background jobs, these are things that are available within the PowerShell. I'm not utilizing any extra like .NET classes or methods. I'm not utilizing any third-party modules that might come from the PowerShell gallery or GitHub or anything like that. I'm trying to stick with as vanilla as I can get away with. So with that being said, are there other things you could do as well? Sure. So there is a new module that was created a couple years ago that basically combines the nature of background jobs with some throttling built into it. So if you look on the PowerShell gallery, or if you look on GitHub, there is something called the thread job module that was developed. It is not, to my understanding, it's not officially supported by Microsoft. So again, whatever you find out on GitHub may not be providing official support. So in some organizations and businesses, that does matter. So I know, like with some of the government and military customers that I train with, that's a huge deal breaker right there. So if you could use the thread job module, it might work better than maybe some of the things I'm talking about here. But again, we still want to understand the concepts of what's going on here. And also, we're using, with method one, where we're going to use the parallel parameter with the foreach-object cmdlet, we could also create run spaces directly from .NET classes if we wanted to. So if you wanted to create run spaces, but you were limited to using PowerShell 5, you could still potentially get away with that, right? Because remember when I talked about method one, this parameter, this parallel parameter on foreach object, that's only available in the version of the foreach object commandlet that comes with PowerShell 7. So again, what if your computer you're running the script from is PowerShell 5, but you want to use run spaces? Well, you would have to create the run spaces directly from .NET classes, which kind of makes that, again, become a little more programmer-ish, a little more developer-ish, if you will. So again, I'm not going to be going over these methods in this particular video. So we're basically sticking with the two methods that I outlined here. All right. So with that, let's switch over to my lab VM here to play around with. All right. So what I have up here is just a simple lab environment. I've got 9 computers in it. I'm connected to one of them at the moment. It's a Windows 11 desktop. I've got PowerShell 5 and 7 installed on it. I've got VS Code installed on it. And I have opened the script that I'm going to play around with here. So I want to adapt a script that I've already made and published a video on and show, again, the different ways we could use this to contact computers in bulk. All right. Now, looking at this, if you want to download a sample of this, I'll have it up in the links with this video. But also, if any of the code in here is a bit unclear to you, you can go check out episode 5 of my Build a Script series, where I go over the building of the script from scratch, right? So basically, we're going to use this because it is a script that reaches out to a computer to gather some information. And it is something maybe you want to point at a whole bunch of computers. Like, hey, I want to get information from 100 computers, 1,000 computers, something along those lines. Okay, so this could be our start that we are going to utilize here. Right? Now, this particular script is gathering help desk information from a remote computer. So it's one of the scripts we build up in the PowerShell scripting and toolmaking class. If you guys have ever taken that from a training center out there, I know I teach that a lot. So this is basically kind of the traditional fare for what you're going to have out there. So what I want to do first of all, though, is just to kind of simplify things a bit here. I want to clean this up a little bit. So I don't want to use it as is. There's pipeline data. There is error handling in here. I want to just try to clean this up to be as simple as we could start with here, just to kind of keep it a bit easy. All right. So with that being said, the script as I wrote it utilized a sim session to contact the remote computer. Right? Now, a sim session is basically a reusable connection you can make to another computer, and it could use either the port and protocol that PowerShell Remoting uses, which is WSMan on port 5985, or you could also configure it to use basically the DCOM or the WMI protocol, which is underneath the RPC family, which is on port 135. So a lot of older legacy networks kind of like using WMI or DCOM, and a lot of more modern networks that have remote management enabled on them utilize WSMan. Right? So in PowerShell 7, DCOM and WMI are not supported anymore. Right? So we could still make a sim session here, but again, I'm not going to in this case, basically because we don't want to have the option for doing DCOM or WMI. Right? So those are kind of considered older, it's an older legacy protocol, not something you find in a lot of more networks that are utilizing more PowerShell 7, if you will. Right? Um, so with that being said, I don't really need this parameter here, so I'm just going to go ahead and get rid of that. All right, so get rid of that parameter, and I'm also going to take computer name here and get rid of the pipeline support. So we're going to get rid of value from pipeline by property name and value from pipeline. So get rid of those. So now we just have computer name, and it is a mandatory parameter and will accept multiple values, right? So I'll also need to rip out the process section here. So get that out of there. And we're also going to rip out the error handling. So I'm going to get rid of the try block there. And come down. If we don't have the try, we certainly don't need the catch section. So we'll get that out of there, and we'll get the closing of the process section out of there. All right. So that leaves us with a little more simple approach here for what we're doing. Let's see. Just kind of clean this up a little here. Actually, I could probably take all of this and maybe tab it back one position. All right, and I think that will do it for, so again, that cleans it up, getting rid of kind of the extra stuff I don't want in here. All right. Let me just take one more glance through this, and I think that's pretty good. So let me save this. Let's do maybe like a file, save as, and we'll go put it in this demo folder, and maybe we'll call this, no, help desk original. And again, I'll take all these finished scripts and I will make them available for download through the link in the video description as well. All right, so we've got help desk original, right? So let's go and try that out and make sure that that kind of works as is. So we've got the help desk original script. Let's go maybe point it at one of my other computers. So I've got a LAN SVR1. All right. And oop, we definitely have something going on there. All right. Oh yeah, because I don't need this protocol section. And since I didn't do that, I don't need this stuff anymore. Okay, and let's try that one more time. Okay, so there we go. Um, all right, so I think that's good enough to start with. All right, so what I want to do to start with here is if you kind of look, this is, let's say, standard fare for what you find when you take like a beginning PowerShell scripting class or toolmaking class or something like that, right? As in, if you want to process a lot of computers, you run it through a for each loop, a for each construct, and you loop through each computer one at a time. Right? Now, this script wouldn't be too bad, um, basically because these are pretty quick queries here. In fact, for each computer, it probably runs at, I don't know, maybe like half a second or something like that, right? But if you were to give this, 10 computers, 20 computers, 50 computers, it would loop through each of them one at a time, right? So the for each construct does not run multiples, right? It would take the 50 computers you were trying to connect to, and it would load one at a time into $PC, and then this code would loop, right, for each computer we wanted to go contact. So that means it would create a SIM session, it would go connect to those computers, remove the SIM session, create a property table with the data I'm looking for, create an object, and then close the loop, right? So it would run all of this, in order for each computer one at a time, right? Now, if you want to get into eventually getting to, like, let's say bulk processing or speeding this up or whatever you want to call it, this approach probably isn't going to work too well, right? So basically, we're contacting a computer, we're running 3 queries against it, right? And then we're saving each of these kind of pieces of info into its own variable locally where I'm running the script, and then I'm constructing the object locally, okay, that I want to output. So while that could work, it's making the computer where the script is running do all of the legwork, right? So instead, I could rewrite this a bit so that all the legwork gets done on the remote computer where we're grabbing the information. Let it send back to me the finished object that I want, right? Don't just go get pieces from each of the remote computers and then assemble it, on the computer where your script is running later, right? You can kind of do it all, do it all there. Let each remote computer do all that legwork. So what I'm going to do for that is I'm going to use PowerShell Remoting to do it. Okay, so the only reason why this script here didn't utilize PowerShell remoting to begin with is kind of the design intent was to make it so that the SIM session could use one of 2 protocols. Use the PowerShell remoting protocol, WSMan, or use kind of the older legacy WMI DCOM protocol, right? So we're going to change this again around so that it utilizes PowerShell remoting. So we're going to throw into here an invoke command and going to computer $PC, and then we have our script block, and then we will wrap all of this. So again, all of this will run remotely here on the computer in question, right? So, so we'll go change that around. Um, let's see. So we don't need that remove sim session line, so we can get rid of that. Build the property table. All right, and then so that right there would be our script block that we wanted to run. All right, so let me maybe tab this. So that kind of looks like it's running inside that script block. Okay, so we've got invoke command, this script block, and so that will now use PowerShell Remoting. All right, and all of the work is being done on the remote computer. So let's go ahead and give that a shot now. All right, so let's see. Maybe that computer is taking a holiday. Let me try a different one. And that computer is also taking a holiday here. Let's see. Let me try one more. Okay. So let me go ahead. I'm going to pause the video for a sec here, figure out what's going on in my lab environment, and get back to you. So give me one sec. All right. So looks like I was just being a bit foolish there. So for the past week, my lab environment that I was using for my class, all the VMs started with the name LON. So I've kind of got that on the brain right now. And this lab environment that I had built up for this, I used a different naming based on a different setup that we use. So the VMs here start with SEA. So that was my mistake. So if I reach out to the correct computer name, I do get a result back. Right. Now I do want to clean this up a little bit. Notice, for instance, the computer name is blank. We have this extra PS computer name added on and this run space ID added on as well. So I don't really want those things. So we want to clean that up a little bit. So in here, if I want the name of the computer, remember in the property table where I build this out, remember this code now is all running on the remote computer. So it doesn't know what $PC is. So that's a variable that exists on the PowerShell session where you're running the script from. So if you just want the computer to go grab its name, you could use $env colon computer name, and that'll populate that out. And then the other thing, if I don't want some of that extra output here, if I don't want PS computer name or run space ID, I can basically get rid of that data in the information coming back if I wanted to do that. So first of all, up in invoke command here, I can go add another parameter onto that called hide computer name. Okay? And that'll get rid of the PS computer name property coming back so we don't see it. And then the second thing to get rid of the run space ID is I take where my cursor is now on line 31, that's the end of the script block, and I could take the result of that, bring this over to maybe select object, and pick, let's see, so I want all of the properties coming back, and then I want to exclude the property run space ID. So let me go ahead, save that, and see if that is going to do it for us here. All right. Okay, so I messed up something. Oh, typo. That should be $env. Man, gotta love typos. And there we go. Cool. So now we've got the computer name populated, the rest of the information that the script was gathering, and away we go. Okay, so now let's actually get into doing some stuff in bulk here. Okay. So now that we have the invoke command set up, basically what we could do with using, let's say, the foreach object commandlet is I can replace this for each with foreach object. So what I want to do, and let's go save this as a new version here. So this will be help desk for each is what we're looking for, right? So what I want to do here is I want to get rid of the for each line, and what we're gonna start with, we're still going to use this script block right here. So I still want to send this to each remote computer. That's perfect, right? So, but how I want to start it here is with gathering all of my computers, right? So they would all be in the variable $computer name. Why is that not tab completing on me? So they would all be in $computer name. And what I want to do is take that array and pipe it over to foreach object parallel. So foreach object, there we go, parallel. And we want this script block here to run in parallel, right? So that is going from there, and we're going to bring it down here, and we're going to close it right here. All right. So basically, what PowerShell is going to do is it's going to run all of this in parallel, meaning it's going to do it once for each computer name that's in $computer name. All right, so that'll go ahead and run everything inside of here, which is again the invoke command. I do want to change that around because again the computer name is now not $PC that it was with the foreach object that we used earlier. It would now be the object in the pipeline, right? So that would be $underscore. All right. So again, with foreach object, it sees the computer names coming in from the pipeline here. So that's being piped in. So if we want to work with each one, we use the automatic variable $underscore to represent that. All right. And then this script block here is still all the code being sent to the remote computer. All right. So the difference now is it's going to, because we're doing foreach object parallel, each of these invoke command lines is going to run to whatever the throttle limit is, right? So in this case, it was 5, let's say. All right. So let's go ahead, save this, and see if it runs properly with a single computer. So that was, so what was the name of that? That was help desk for each. Let's give it a computer name. Something's not right here. Just giving a scan quick. Oh, that's right. I got an extra close there. Okay, let's see. Okay, so basically what was happening there is when I was trying to type out my commandlet and I tried to tab complete computer name, it wasn't tab completing. So if the parameters don't tab complete, it normally means something's wrong. So let's come back in here and let's give this a shot, and away we go. Okay, so that contacted one computer. Now let's feed it. Let's say like a bunch. So I have on this environment here, I have all of my computer names in a text file here. So these are all the computer names in my lab environment. I've got 1, 2, 3, 4, 5, 6, 7. So I've got 8 of them. All right. So what we'll do is we'll go kind of point this to all 8 of them. So we'll go load that in by using get content. And so that was host.txt. All right. So we go run that, and all the computer names are contacted. All right. So it looks like we got good results there. And so that contacted all 8. Now, to kind of make it like a true, let's say, representation here, we probably want to, obviously 8 computers isn't a lot, so we need to maybe loop through each of them, right? So I apologize, I don't have like a corporate network to play around with here. Most companies don't want to volunteer one to me. So I'm just going to take these and we're going to loop through them. So let's do again. So that's so I just duplicated that twice. So that would be like 24 computers. So maybe we'll save that. All right. And because this code runs pretty fast, I want to try and slow it down a little bit. Okay, make it like maybe, how things would affect in a true environment, right? Like, where actually like the network's being utilized. So what I'm going to do is I'm going to make each of these take a little longer. So maybe I'll just, put a 1-second sleep in each of the code that's running remotely, so that each computer takes at least 1 second to process, which is probably more typical of what you might find like, just overhead on your network, utilization, I don't know, the computer's doing other stuff, whatever you want to term it as, right? So now, if I go ahead and I did save that, so if I go ahead and I run this, it obviously takes a little longer, right? Because each computer is sleeping for a second, right? And I'm looping through 24, okay? So that took a little bit of time there, right? Now, if I want to know how much time, we could use, let's say, measure command and the expression would be this, right? So let's wrap that inside of a script block. And so it'll take however, it'll, measure however long that takes. So we're not going to see any output where it's just timing it, okay? Because again, we don't need to see the output. It's pretty basic. So basically that took 7 seconds to process 24 computers, each of them taking individually, let's say a second, right? So that was pretty good, right? And again, remember for the foreach object parallel here, you could increase it from its default. So it does 5 computers by default, but I could potentially, throw in here, like a throttle limit, maybe make it more, right? In fact, you could even make this a parameter, right? So if you wanted to kind of control that, so if I change the throttle limit to 10, let's see what this does for the time here. So, oh, my bad. Put that in the wrong spot. All right, so let's get that there. All right. So yeah, the script block goes obviously with the parallel. So I totally just broke that. All right, let's try that again. Gotta love live demos. All right, so let's go ahead and run to that. And now we're doing 10 at a time, and notice how it took 4 seconds this time, right? So up here we did 5 at a time, and to do 24 it took 7 seconds to process. And by doing 10 at a time, it took 4 seconds to process, right? Now, secondly, well, what if we didn't do any of this at all, right? What if I had the original here? Do you want to trust? Yes, I do. What if I was just looping through them like one at a time, right? So let me throw the start sleep in here as well. Seconds 10, right? And let's try the original, and that's going to loop through again one at a time, right? So let's do help desk. Help desk. Come on, tab complete. Okay, we've got the help desk original, right? And if I go time that, right, each computer is taking a second, and it's got to loop through 24 of them. So it looks like this will probably take 24 seconds, right? So just doing, again, one at a time, which is, the approach that a lot of people learn at the very beginning of scripting here when you're first learning how to put PowerShell scripts together, using the for each construct. So it does work, but if you need to process a lot of computers, it may not be the best approach for what we want to do. All right, so we're still kind of waiting for this to finish here. Again, each computer taking a second, right? So that is taking its sweet time to process there. In fact, it shouldn't even be taking that long. All right, so this thing is still cranking here. So again, just adding that that bit of sleep. Oh, I did 10 seconds. Oh man. Sorry about that. That was supposed to be a 1. So in fact, let me save that back to being a 1. I was wondering why this thing was taking so long. Let's see. Let's cancel that, and let's run it again. Each computer taking a second, right? And then that should now process in 24 seconds, which should not be too long there. So that would make it process in 240 seconds, which is the other one, which is definitely a few minutes there. All right, so this should process a little faster, but again, notice again, it's still slow, right? Because again, each computer is taking 1 second to work its way through, right? So again, with that slight pause and whatever, you'd figure, hey, each computer took a second, that's 24 seconds, but in reality, right, that thing took 35 seconds to process. So 35 seconds when pointing this to 24 computers, and the for each object here with the throttle limit at 10, that changed that down to 4 seconds, right? So that's pretty good, right? 35 seconds down to 4. So that definitely picked up some speed that we could take advantage of. All right. So the second method I want to go over is, again, with for each object, with the parallel command there, what we have to remember is that this works with PowerShell 7, right? So the computer where the script is running has to be PowerShell 7, right? All the code inside here, like invoke command, I'm doing get sim instance, where object, making a new object, right? New object, right? So all of that is all pretty standard code. So that is sent to the remote computers. So those remote computers could be PowerShell 5, no problem. Okay. Biggest issue is obviously PowerShell remoting has to be enabled on them. All right. So the computer where the script is running has to be PowerShell 7. The other computers could be whatever. All right. The biggest issue again is remoting enabled. But let's say the computer you're running the script from, there's no possibility you could make it PowerShell 7, right? So hey, I'm running this off my computer. My computer is PowerShell 5. There's really like nothing I can do. So what can I do if I still want this to process in bulk? Or, I'm going to run this script off of a server. The servers don't have PowerShell 7, right? So the server I want to use to run the script from is PowerShell 5. So again, this would not work. So what could we do instead? All right. So let me first of all, let's go back to the original, because that's again the one I want to start from, and let's go save this as, and we'll call this, instead of help desk original, we'll call this help desk dash jobs, because we're going to use background jobs. All right. So help desk dash jobs is what we want to use here. All right. Now, the beginning part of it, I'm still going to do the for each construct here, right? So we're still going to loop through the computer name. So we're going to have all the computer names in $computer name. A single gets loaded in $PC, and then this will loop for each computer name, which is doing the invoke command. All right. So what I want to do with this is with invoke command, it does have a parameter called as job, right? So I could tell this that I want it to run as a background job, all right? So we could utilize that that as job parameter. Now, what does that get me? Well, by making it run as a background job, it immediately clears this up, right? So with invoke command, it doesn't have to wait until this is finished processing. By making it a background job, it immediately finishes the loop, and then we can go back up to for each, get the next computer name, and run an invoke command session. And again, that one becomes a background job, right? So if I left this as it is, it would run all 24 computers as background jobs, literally as fast as it could fire through them, right? So each one would process in the background, right? Now that's not necessarily what I want here, right? So I do want it to run as a job, okay? That's not disputing anything with that. But before I complete the loop here, because remember, invoke command, right? That's just part of the for each loop here. So before I finish up with the current iteration of the for each loop, I want to put a little logic down here, right? So what I want to do is I want to take, let's say that that information. So I don't need this line here. I'm going to deal with the output separately. So I have this here, and then separately from that, okay, so that makes the background job. And then I want to put a little bit of logic in here. So I'll use maybe like a while loop, right? That's kind of works for this scenario. So what I want to do is I want to look at, let's say the get job state of running, and maybe do something with that. So in fact, let's say I need to wrap that in a set of parentheses as well. So let's do something like this. So get job state running, let's grab the count on that. And if it's, let's say, I don't know, greater than, I don't know, let's maybe start it with 5, right? What do I want to do? So let's say what I want to do with it is maybe we'll do a get job, and we'll pipe that over to wait job, which is basically a pause. So I want to wait until any of the jobs have basically finished if you're higher than the amount of jobs you should be at. Right? Is basically what I'm looking for. Right? So so um, with that, that should provide basically kind of like a throttle, if you will. Right? So with it here, we take get job and then the state of running, and then we look at the count property on that. And if it's, I don't know, let's say greater than or equal, let's say, to 5, we will pause it. That's what wait job any does. Right? So that will provide the pause um, until one of the jobs finishes. So it's basically like, if you kind of think of this as a loop, the for each is going to start looping and until it gets to 5 background jobs that are currently running, right? And then this will make it kind of wait there, all right? So let's maybe, I wondered why the VS Code script editor is not happy with me at the moment. Um, that is legitimate. I gotta be missing a closing something somewhere. So we've got the opening for each there, closes down there. That's the closing of the script block, which was opened up there. And then in here, it is just not liking that dot count, which is oh, there we go. Okay. Knew I had an extra somewhere. All right. So again, sometimes when you're doing the code, it makes sense in your head. All right. So we go ahead, we get that, and then also, while we're in the current iteration of a loop, if there's background jobs that are completed, we want to go get them. All right. So we're going to use get job this time. So we'll do a get job, and this time we want the state of completed. Right? And actually, running does not have to be in quotes. Just kind of clean that up. All right. So state completed. And then for each of the completed jobs, we're going to loop through doing for each object. Let's do a process. And what do we want to do there? My apologies. That freaked out a little bit. Okay. So let's, did it again. I'm trying to hit a carriage return, right? So open, let's do that. All right. So, so in this process, what do I want to do? So if there's completed jobs, I want to receive the job. All right, receive job, whatever the current one is, because again, we're in a for each object loop here. So it's going to take all the completed jobs and kind of load them into the pipeline. And then we're going to run this code once for each completed job. So we'll do receive job. So that'll receive that one. And I want to get rid of it when I receive it. Okay, so I need to use auto remove job and wait to tell it to do that. And then I'm going to do my select object, property star, and then exclude. I don't want that run space ID anymore. All right, so that'll finish up the output there. And that could be good. All right. So basically that's inside of the for each, right? So we're going to loop through as many of these as we can. Right, let me kind of bring that back over here. So inside the for each, we're going to contact via PowerShell Remoting each computer as a job. So that means the invoke command is going to finish pretty quick, right? It's not going to wait until it hears back from the remote computer. It's immediately going to move on to the next. That's what as job does. It kind of makes each one a background job. So those are going to run. And then we have a little governor right here, which is going to pause it when the background jobs that are running get to be 5 or more. All right. So that's what this line of code is doing. It's basically pausing it. And then once a background job that's running finishes, now the count falls below 5, and then the script can now proceed. So this would now get any background jobs that were finished or completed, receive them and remove them. All right. So now that will loop through. Now, after the last computer has been entered in here, remember there could still be some background jobs that were running. So after the for each is all done, I still need to tell PowerShell to wait for the rest of them that were still running. All right, so I'm going to do this after this for each here. I'm going to use another while construct, and this time I still want, again, the ones that were running. So let me just grab this code here. So let's tell it to wait job. If the state of running is greater than 0, right? So that's what we want here. So if there's still ones running, pause. And with wait job, it'll wait for all of them to finish. Up here, where we did wait job any, I just want one of them to finish to keep moving on with the loop, right? So if you have 5 running, wait for one to clear, then receive it, and then go back and loop again, right? So it's going to keep 5 open at a time, right? Or 5 background jobs running at a time. So here, to finish everything up, I want to wait until they're all finished, And then I could go kind of do the same thing here, where I run this get job line to go grab them. So we'll just throw that there, and that should now get the rest that were all finished up. All right. So let's go ahead and run this, and let's see what we have here. All right. So let's first of all, let's not run it against 24 computers. Let's not be too ridiculous with ourselves here. So this was help desk jobs, and computer name, let's say SEASVR1. Okay, so can it grab one computer? Okay, it could. All right. Now, one of the things I don't really like is when the background job was created and when the background job was received, I got output here. And I don't necessarily want to see that because that could definitely clutter up the view, right? If I give this another computer, notice you have the background job clutter and then you have your actual output, right? So I really don't want to see this, let's say. All right. So what I could do is where that's happening there, is first of all, with the invoke command, you're running it as a job. That's what's creating that bit of output. So after the script block, what I could do is pipe that to out null. All right, so that way when the background job is created, because each invoke command line is creating a background job, I don't want to see the output from that. All right. And the second thing is when I am getting the jobs, um, get job, wait job, any, I think that's actually creating some output as well here. All right. Because get job doesn't, or I'm sorry, not get job, receive job doesn't do that, but I think the get job wait any. Let me pipe that to out null as well. So that's one there, and then the wait job out null there. All right. So let's go ahead, save that, and let's go see if the output's a little cleaner. Cool, it is. All right, so we don't see the status of the background jobs. They're just kind of cranking in the background there. All right. And now let's maybe go and send a lot of computers at this thing. Okay, so let's do the measure command, and let's change again the one we're looking at. So this would be help desk jobs. And let's see how long that takes to process. Remember, we're doing 5 at a time. Okay, so that took 7 seconds as well, doing 5 at a time. And then let's maybe up the governor on this thing here. So let's say we're waiting maybe greater than 10, something like that. Right, let's go ahead and run that. So now it could do 10 at a time. Let's see how long it takes to go through 24. Okay, and again, we cut that down to 5 seconds. All right, so kind of interesting. Background jobs was a little slower, is a second slower than using the foreach object with the parallel. So background jobs are going to be a little slower than run spaces, I guess. So 4 seconds versus 5 seconds for 24 computers. So again, you can kind of extrapolate it out from there. And the other thing is, again, I might not want the kind of the governor here to be a static value, right? Like maybe I want to make a parameter out of that, right? So up in my parameter block, right after computer name, maybe I have, this would be, I'd want it as a number, an integer. We'd want maybe, I don't know, maybe max sessions, I don't know, something like that. And then maybe set it to a default value, right? So maybe we default it to 5, and then down here, instead of having that, we use the variable instead, right? And so save this. And now if I run the script on its own, right? So we're just running help desk jobs on its own. So that means it's doing 5 at a time. But I could utilize that max sessions parameter that I added in to maybe make it go a little faster. So for help desk jobs, we'll do max sessions and maybe we'll do 10. Okay, so now we have a parameter that can control how many background jobs it's keeping open at a time. All right. And again, you could have utilized that in the for each as well here, right? So again, throttle limit just takes an integer. So up in your parameter block, you could have gone in and again, as a parameter, maybe I'll call this one throttle, and again, maybe default it to something, right? Actually, you don't even really need to, in all honesty. Yeah, you should default it to something. So maybe default it to 5. And then so now $throttle, and away you go, right? So if someone does not use the throttle parameter, that's 5, right? So it'll do 5 run spaces at a time, and if they want, they could, up or down the amount and utilize it that way. All right. So anyway, so as I mentioned, I will have these scripts available in the link in the description if you want to check that out. The other thing I do want to mention, I did not utilize in the original script, I took out the error handling, I took out the pipeline stuff. So if that's something you guys might be interested in, like how would I work pipeline into these different scripts? How would I do error handling in each of these different scripts? You can let me know in the description, and that can maybe be a follow-up video onto this. Don't want to get into this now because I'm already getting pretty long here, coming up on about an hour. So we'll end that for here, and hopefully you guys got a little taste of what it might take to be able to process scripts that have to contact a lot of computers, and some ways we could do this quickly here. So utilizing the foreach-object commandlet with the parallel parameter, and utilizing background jobs. So thanks for tuning in. If you enjoyed it, please allow me to ask you to subscribe to the channel, give me a like, give me a comment. It all helps the YouTube algorithm figure out that this content may be stuff that you want to see. So thanks again for tuning in, and we'll catch you in the next video.